San Francisco Airport project at the moment, and I'm here with Juani Fernandez. She's a BIM coordinator on our Transbay Terminal project, which is a $1.2 billion infrastructure project in downtown San Francisco. So our presentation today, coordination closing the loop between design and construction, we organized this in 5 pieces. We want to look quickly at the history of coordination throughout the time, then look at the current situation in coordination in our company. Then we will look at the obstacles and the root causes for those, and then we will finish and look at a project where the stars align and we can really close the loop between design and construction. So history of coordination. If we go back in time, the early stages were first civilizations. The coordination was in one hand, and if you look at the example in Egypt, it was the royal master builder which was running the coordination. This continued in time in the medieval ages. Still, the coordination was in one hand. In this case, it went over to the stonemasons, and it still was one person. Then in the late 18th century and in the 19th century, it's the one-hand coordination diverted into segregating in engineers, architects, and builders, and that even became more pronounced in the 20th century. And so now, these days, at least in the US, the coordination is in hand of mostly of the general contractor. Looking at the history, it's important also to look at the building information modeling, how it became. Chuck Eastman, so you already saw him yesterday, and you know what he's doing, so that was really a pleasure. But he also, what was not mentioned about Professor Eastman is he was co-writer of this book. It's almost a Bible now. There's a previous version further back. But what I want to point out, in 1974, Chuck wrote a paper, and it was basically summarizing exactly what we talked about, building information modeling. So if you look at the abstract, so he called this the building description system. I highly recommend to read this paper because you think like, he wrote this in 1974, and we're still struggling to make this happen. So if we compare this to other industries, computer-aided design in manufacturing, they, in the 80s, started using this for analysis, for reduction errors, and for factory automation. That continued like in the 90s, computer-aided design with computer-aided manufacturing, starting closing the loop, and then in the mid-90s, computer-integrated manufacturing was becoming more or less the standard, where like closing the loop between designing, engineering, and manufacturing. Comparison, like same time frame, you look at the construction industry, the adoption of AutoCAD and MicroStation was just like augmenting like the 2D document production. And then in the pre-days of 3D modeling, we still were working with the light table and coordinating the 2D drawings.
So I'm going to start explaining what is our current workflow on BIM coordination in the operation side. We all know why we do BIM, why we try to move forward on time all the major design changes when they are more cost-effective to the project. But it also gives us benefits during the construction phase. The activities usually are easy to plan. We have a better workflow. The team, improve the team communication and collaboration. And it gives us economical benefits, and also it's easy to meet the deadlines and the schedule. But what do we need for coordination before we even start? We need to make sure that we have the basic elements to set the team for success. So we need to start with the contracts. 3D coordination has to be in all trade contracts. We need, of course, the BIM Execution Plan has to be project specific. We need to have clear project settings, alignment, origin points, very important, all the naming convention, all of that. We need to agree on the software and the platforms that we're going to use. And then we also need a trade coordinator that has the technical knowledge, the management skills, and the construction experience to help the team through the coordination process. So the coordination process really is a cycle that starts by collecting the models, identify the issues, solving those issues, and goes again until we resolve all the issues that we find. And then we communicate this coordinated system into the field. So let's look at the cycle. All the trades produce their own models. They are responsible of their content of their model, and they upload all the models into the cloud. We use a cloud-based system, and then the coordinator collects all those models and create the merge model also in the cloud. So it's a live merge model where we can see the latest and greatest version of everything 24 hours a day. Of course, we do class detection too. We have a weekly class detection. We download this merge model from the cloud into Navisworks, and we create viewpoints with all the clashes and the issues that we want to track. And we use that merge model on the coordination meetings. We record there all the action items and the responsibilities to the trades. And then after the meeting, we save that and we email to everybody so they know they have a record of the action items. But even more important for us is clash avoidance. What we understand for clash avoidance is when we have the live merge model available for the whole team, and they can get into the cloud anytime, they can track their updates, they can create their own clash analysis, and they can solve their issues before even we have to go into the coordination meeting. They don't have to wait for the coordinator to tell them what is wrong and what they need to fix. They can go by themselves without having to wait for every week merge model. Finally, when the systems are coordinated, we froze the models, sign them off, and then we produce the shot drawings from the coordinated model. We also create a multi-trade drawing that we submit for the design team review and also for field verification. So let's take a look at the top 5 obstacles or issues that we find along the way. Let's start with the goal misalignment. So this happens when the trades don't have a clear vision of what their role on the coordination is. So to avoid this, we have to communicate at the beginning. We have to know what do we expect from them. They need to know what we expect. And then we create the BIM execution plan as a team. We engage into creating everything together. And then technical training. Of course, we know that people is the key factor behind any process, but we need to identify what which person on the team needs some extra support so we can provide this help or training so the whole team can move at the same pace. Resources. Many times the trades, they understand what their role is in coordination, but they don't really understand how much work they have to put into the process. So again, communication is key. We have to talk. They need to know what do we expect from them so they can allocate the proper resources to the process. Time. Maybe we got the project when the construction days is already too close, or maybe the buyout process is too late and we don't even have the people that we need to coordinate. But whatever case it is, we need to plan in advance and we need to create a coordination schedule that is behind the coordination schedule, construction schedule, sorry. So we know, we have a clear idea of how much time do we have to coordinate, and from there we can prioritize if we have to, how much time we have to coordinate certain areas or systems, or at what level each system. And finally, rework. Sometimes it's unexpected, sometimes it's expected, but it's really challenge for the whole team. So maybe we have a design change that comes when we are almost through the coordination process. So this is really on the design team's hands to try to move forward on time all the major changes so we can try to avoid this rework associated with so many changes.
So now in this last section, we want to look at projects where all the great success factors align and we can really live the future. So I have the pleasure to work on this airport project and with in a joint venture with Austin Commercials. And so I want to show some what we're doing here. So in my mind, those are the 5 success factors in having a success closing the loop between design and construction. Early involvement, collaboration, interoperability, data accessibility and exchange, and contracts. And then if those stars align, then what in the past was like one master builder becomes now the master builder collaboratively developing the success story. So early involvement, Juani and other speakers, they mentioned that project origin and setting the goals is important to have documented in or agreed on in the BIM execution plan. But on projects where those basics are already set by guidelines from the owner side, even before the designers get into the game, then everybody starts like on the right foot, and it really speeds up the efficiency of building a successful coordinated project model. And we look at this in the different stages throughout the life cycle of a project, and like visualize this in like where we use and how we use the building information model. Other early involvement is like early design coordination. So when we get access to the data early on, we can do all kinds of interesting things like massing sun studies, energy analysis, daylighting studies, and also like we can get access to the data and do conceptual estimating, which gives like a instant feedback to the design team. On the contract side, we already heard that the optimal is like IPD, integrated project delivery, where the early involvement is enabled to have trades, the GC, the main engineers and designers at the table in developing the project together. The next step down would be design build. In our case, because it's a public project, that's what we have, but it still enables this early involvement. Then that's the owner contract side, but on the subcontract side, if there's the possibility to define those contracts and have like a model progression specification where it shows the different stages of the project and the design phase, and agrees on the team agrees where to what level of development the model is developed for the specific detail portion. Then that's a high success rate for building a very efficient model. And so the same is like if in this contracts it's clear which trade has to model at what stage, then this can inform the buyout, because in often the cases metal stud framing is bought out delayed, but this is the most critical one for all the MEP trades, to have them as part of the team to model early on. Collaboration. So their technology is one interesting piece which really enables this now, even on areas where we have traditional contracts in place. The cloud solutions where everybody has access to the data enables, even with the design bid build contracts, to make the collaboration happen without even asking for it. It's fascinating. So, and then here, like, show a picture of like a chat window, what people use in the design industry, in the software industry, to chat between the designers. That's now happening also in the construction industry between the designers, like the real-time working with people not co-located, even apart. Beside the technology, project co-location, we heard it over and over, is really enhancing the face-to-face problem solving, which is the preferred way. And it also, like, it gives like better basis for centralized data in a project server and access. And also it's like the visualization of the big room data on the walls is also a big plus for having the project co-location. So in our case, we have that all in place, and that's really, it's living a dream. Regarding interoperability, we heard a lot about IFC and BCF and COBE, and I think it's great, but my personal opinion is different. I think the ideal way is like if you have a uniform software platform where the designer, the builder, and the end user, they use the same design platform, because then you can access, everybody is in the same space designing and looking at this thing live 24/7. Which is, I think that's a lot more efficient way to do, instead of like having those exchange formats. So yeah, there are only a couple platforms which are able to do that. But in my mind, in the past, I had this on a board project, and on this project it's the same. It's really speeding up the whole collaboration between the designers and the builders. Data accessibility and exchange. So the concept of the data lake, that's in my mind the solution. So there's a data lake is a non-structured depository on the cloud where raw data is stored in its native format, and there are now tools out there where the team feeds in independent from the native form format. But the tools enable to deep searches to view the data without having the native software on the computer, and that basically enables us, independent from the owner or the builder or the end user, they could look at the data just to have the capability to look at all the data available, independent from the software. So that's, I think, the future, and there are some solutions out there which can start doing this, and that's basically the future I'm at the moment living, and it's getting more exciting. So it's not as dark as it sometimes looks. On some projects, the stars align. Thank you.